My producer just said, here goes nothing, I hope it sticks, and I'll second that motion. Again, July 31st today. This is homework 32. The first part will be review. That means you got to listen though anyway, be listening. And then the second part will be new stuff for you. Right, the first problem on your paper that Mrs. Bingaman will hand out, draw the sine and cosine curve for theta being in between 0 and 2 pi. Should be done already, doesn't take long. Well, maybe a little bit longer than that. But your sine curve should look just like this. Should have half a circle above the x-axis, half a circle below the x-axis. We're going from pi to 2 pi. This would be half a pi right here, and this would be 1.5 pi's or 3 pi over 2. It goes up as high as 1 and as low as -1. My cosine curve, that's a quarter of a circle, a half a circle, and then another quarter of a circle for the cosine curve. That's going to be at pi, that's 2 pi, this would be half a pi, not drawing a scale. Jessica just said that this was the best one I ever drew. I must have really drawn some bad ones in 2014 calculus here, Jessica, because that looks like it's much more than half, but oh well. But it's better than what I did before.
Yes.
Okay.
You've come a long way.
Yeah. And I could be a little bit lower there to be down -1, but you should get the gist of it. Okay, then the next problem's on the top row of your homework. Complete these 30, 60, 90s. If the shortest leg is 1, the hypotenuse is always twice as long, and that's what you should memorize. The 30, 60, 90, the hypotenuse is always twice the shortest leg. If you can't remember what this is, use Pythagorean theorem. If you do, you'll get square root of 3. I have that memorized, but I've been doing this for so long that I should have it memorized. 45, 45, 90. Well, if two angles of a triangle are equal, opposite legs are equal to each other. And then you could use Pythagorean theorem, or again, if you have it memorized, that's a square root of 2. Okay, give the value. First problem, cosine of pi over 2. Well, go to your cosine curve, pi over 2. Where is that curve? It's up 0. There'd be your answer. Your first one is 0. Oops, I don't want to do that.
Well, you were off to a good start. No, I'm kidding.
Yeah. Oh, thank you very much back there. Okay, you're 0, and I always tell you to circle your answers. Why do I underline it twice, Jessica?
So you know it's 0.
What do I think it is if I don't I always think it's a donut and then I get hungry. That's why I underline that 0 twice
Oh.
there. Maybe
Is
I
it
never told
really?
you.
I don't remember you ever saying that, but I'll
Okay,
take
next
your
one,
word for
sine
it.
of 3 pi over 2 in your paper. Sine, go to your sine curve. 3 pi over 2, that would be 1.5 pi's. That's going to be a -1 for that answer. Next one, tangent of pi. Where's my tangent curve? Where's my tangent curve? If you make a tangent curve with the graphing calculator, it's going to be ugly. So let's do this with tangent. Tangent we know is sine over cosine. So that's going to be sine of pi over cosine of pi. Tangent is sine over cosine. When you were in pre-calculus, you're really good at that. And that's one of the things I expect you to know this year. I don't expect you to know a lot of trig, but that's one of the things. Sine of pi I can get from my picture is 0. Cosine of pi, go to your cosine curve. Cosine of pi, that's down 1. 0 divided by -1 is once again a 0 for that answer. Next one, cosine of pi, column. Yep, -1. Next one, sine of 2 pi, Tommy. Sine of 2 pi. I hope you said 0. Yep, sine of 2 pi, go to your sine curve, that curve is up 0. Tangent of 3 pi over 2, well once again, we don't have a tangent curve, so we'll go like this. Charlie, go to your sine curve, what do you have for sine of 3 pi over 2? Sine of 3 pi over 2. Trevor, go to your cosine curve, cosine of 3 pi over 2. Trevor? Trevor, can you divide by 0? You can't divide by 0. Mr. Holbert can't divide by 0. Mrs. Roush can't divide by 0. God can't even divide by 0. Nobody can divide by 0. That's undefined, or you can put does not exist. Either one of those would be an okay answer on that one. Nobody can divide by 0. Okay, next row. Cosine of pi over 3. Ben, go to your cosine curve. Pi over 3. You can't tell, can you? Okay, so we have to do this. Almost all the time we're in radian mode. Let's go back to some geometry and the degree mode, and what you're supposed to have memorized is 180 degrees is the same as pi radians. They want cosine of pi over 3, so I need a pi over 3, so let's divide both sides by 3, so that's going to be 60 degrees. So what I really want now is cosine of 60 degrees. I think I wrote that on your paper somewhere. Ben, cosine means, okay, adjacent over hypotenuse. So from the 60-degree angle, from this angle, the adjacent side is 1, the hypotenuse is 2. There would be my answer would be a 1 over 2. Okay, for pi over 3, I cannot use the sine curve and cosine curve. I have to go down to these things and go back a little bit into degrees and geometry class. Sine of pi over 4. Once again, 180 degrees equals pi radians. 180 divided by 4 is 45 degrees. So what I really want is sine of 45 degrees. Tommy, sine means, and Tommy, from the 45-degree angle, the opposite over the hypotenuse is, good, I think, 1 over square root of 2. Okay, and you can leave that square root of 2 in your denominator. Last year in pre-calc and in algebra 2, we always said never leave the square root in the denominator. Now in calculus, we don't care so much anymore. We can leave it in there. Tangent of pi over 6. Okay, that 180 divided by 6 would be 30 degrees. So what I want is tangent of 30 degrees. Trevor, tangent means, and Trevor, from the 30-degree angle, the opposite over the adjacent, 1 over square root of 3. Colin, does Trevor know what he's doing? Cosine of pi over 6, go ahead yourself on that one. Pi over 6 is 30 degrees, so I hope you went cosine of 30 degrees. Cosine means adjacent over hypotenuse. From 30, square root of 3 over 2. Yep, there you go, square root of 3 over 2 for your answer for that last one. Okay, now we're going to do some new stuff. Okay, Jessica, I'm going to need you on the graphing calculator. Go to your y equals, Jessica, clear those out of there. Punch in sine of x.
Whoops.
Go to your y equals, punch in sine of x. Okay, and if she hits graph, it's going to be ugly. Go ahead. Oh, that wasn't too bad. But let's get a better window. Jessica, go to window. Let's go 0 to 2 pi for our x's. She's looking for the pi. She found it. For x scale, let's go pi over 2. Okay, for the y's, Min, how about negative 2 to positive 2? This should be a nice looking window and graph. And doesn't that thing look just like this thing? They should look the same. Okay, she went 0 to 2 pi, and she went from negative 2 to 2. She's got the same curve I have there. Okay, Jessica, let's change our window once. Go window, and go 0 to 6 pi. Last time we were 0 to 2 pi. Okay, everything else is going to leave the same. And graph. Well, what do you know? I want to show you what happened here. If we went out to 6 pi, right here would be 2 pi. Right to here would be 4 pi. Okay, so here is this curve again, which is this sine curve right here again, the exact same thing. Okay, and then right here it does the same thing again, from 2 pi to 4 pi. Right there it does the same thing again. So what we're trying to say is every 2 pi does the same thing over and over and over again. Okay, here's how that's going to help us. Okay, next problem, I want to find sine of 5 pi. Oh, did we say every even pi it starts over again? Every even pi? So Jessica, go change your window to 4 pi to 6 pi. Okay, well that one was okay already. Go up to the top one and put 4 pi. Yep, there you go. Okay, doesn't that look exactly like this one again? Exactly like this. Right here is the 4 pi. Right here is 6 pi. Every 2 pi's it starts over and does the exact thing over and over and over again into eternity in the positive direction and the negative direction. Okay, if that's 4 pi and that's 6 pi, then this would have to be 5 pi. Jessica, where's that curve at when we're over 5 pi?
It's halfway in the period.
How far up is it? Or how far down is that curve? 0. Jessica, why do I put those lines under my 0?
So you don't think it's a donut?
So I don't think it's a donut, so I don't get hungry. Okay? Okay, so that's what we're going to do in all these problems here, is just we're going to go out, every 2 pi's, it starts over and it's the exact same thing. Okay, now you're not going to have a calculator when you do this. So what you're going to do when you see they want sine of 5 pi, you're going to make the exact same picture we made for our sine curve, but you'll say this is 4 pi, this is 6 pi, so right there's got to be your 5 pi, and that curve is up 0. Okay, Jessica, go to your y equals, and clear out sine of x, and punch in cosine of x. Holy cow.
What just happened?
I have no idea. Did you punch, go to your y equals again.
I have a blank screen. Don't worry, I got this. I played Game Boy as a kid.
She's trying every little thing in the book to get that. There she goes. Good. I have no idea what my producer did, but she's got it going again. Okay, punch in cosine of x. And then window. Go 0 to 2 pi again. And graph. Okay, and that should match up with my cosine curve here.
Ciao.
This is 2 pi out here. This is 0 pi. Right there would be 1 pi. Exact same picture as this one. Okay, so we're going to want on this problem cosine of negative 12 pi. Did we say every even 2 pi it starts over again? So go to window, Jessica, and punch out negative 12 pi to negative 10 pi and graph. We're going negative 12 pi to negative 10 pi. Isn't that the exact same graph we had up there earlier? Every even 2 pi, it's that thing over and over and over again. That makes this an easy problem. Charlie, right here's where Jessica put negative 12 pi. Here's a negative 10 pi. Right here would be negative 9 pi. Charlie, where's that curve at? When we're at, when my x or my theta is negative 12 pi. It's up 1, right?
That should not be negative 9 pi.
That should not be negative 9 pi.
That should be negative 11.
Negative 11 pi. Good catch. Come on out here. Come on out here and take a bow. She said she saw me make a mistake in one of my others and wondered if she should say something. And I says, if you see me make a mistake, you let me know. And she's correct there. Thank you. If you ever have any questions, you can go to Jessica or me for help. Probably her. Okay, let's turn this calculator off now. Yeah, I think we can do all these problems without the calculator. I think. Uh-oh, tangent of 15 pi over 2. Don't have a tangent curve. Remember, tangent is sine over cosine. Tommy, what's 15 divided by 2? If you have $15, you're going to share it equally among 2 people. How much does each one get? I hope you're saying 7.5. So wouldn't this be the same as 7.5 pies? Okay, so because it's tangent, we have to go like this. 7.5, 15 over 2 is 7.5. Because it's tangent, we have to go sine over cosine. Because it's 15 over 2, I think it looks good as 7.5 pies. Okay, now, what was Jessica just showing us with the graphing calculator? Why did we do that? Every 2 pi that starts over, the same thing. So if I want to get 7.5 pi, first for my sine curve, I will draw this. This is my sine curve. If we want to get the 7.5, I'm going to start with 6 pi. Right there is going to be 8 pi. Right here would be 7 pi. So wouldn't 7.5 pi's be right in there? 7.5 pi's would be right in there, and my curve is at -1, so that's my numerator. Now for cosine of 7.5 pi, I'm going to go like this. My cosine curve is 1/4 of a circle, 1/2 a circle, 1/4 of a circle. Okay, if I want to get 7.5 pi, the exact same thing I did up here. Here's 6 pi's. Here's 8 pi's. Right here would be 7 pi's. We want 7.5 pi's. Right there would be 7.5 pi's. And that curve is up 0. Remember, nobody can divide by 0. Nobody. So this would be a does not exist or an undefined. One of those things would be a good answer. A little bit more work because it's tangent. We have to go sine over cosine. Next problem, cosine of 47 pi. Mrs. Bagman, are they listening? Cosine of 47 pi. Cosine of 47 pi. Count. Here's my cosine curve. Does that go up to 47 pi? Of course not. But doesn't every 2 pi that starts over again? So if that's 47 pi, I'm going to draw my cosine curve. Cosine curve is that 1/4 of a circle, 1/2 a circle, 1/4 of a circle. If we want 47 pi, this would be my 46 pi. This would be my 48 pi. Then right in here would be my 47 pi, and that curve is down 1. There would be my answer is -1. Okay, that's all there is to this. This is what we're doing today. Next one, sine of a -50 pi. Oh no, we'll never get this one. Sine of a -50 pi. Well, let's go to our sine curve. 1/2 a circle, then another 1/2 a circle. Every 2 pi it starts over, so let's start with -50 pi. And going that way, this would be a -48 pi. -49 pi, but I don't really care. I didn't even really care about that. When I'm at -50 pi, that curve is up 0. That's going to be a 0. Okay, with your graphing calculator, take a second and punch out -50 pi and see if it shows 0. It'll probably show something like -2.7 e to the -13th or something like that. That thing is a 0. It will give you a 0. Okay, next problem, tangent of 401 pi. Tangent of 401 pi. Tangent, so what do I do first? As soon as you see that. I'm looking for my tangent curve, I'm looking for my tangent curve. I don't see a tangent curve, so I got to go sine over cosine. Is that where we're at now? Is 18 minutes and 30 seconds on this one? Holy cow. Okay. And now we can finish these. Sine curve, easily enough. Here's my sine curve, even 2 pi, so this would be 400 pi's. Right here would be 402 pi's. So 401 pi's is right there. That would be a 0. Cosine of 401 pi. Cosine curve, 1/4 of a circle, 1/2 a circle, 1/4 of a circle. There's my 400 pi. Right here would be my 401 pi, and that's a -1. 0 divided by -1 is 0 for that answer. I'll do one more, and then you can finish the rest of these yourself. Let's look at cosine of -71 pi over 2. I can't believe I talked that long. I usually talk that long. Seems like maybe I do. You guys gotta start telling me when I'm talking too long. In a tactful way, of course.
Like Brady did.
Oh, yeah, like Brady Smith did when she was a sophomore, yeah. Okay. She asked me once when I substituted here the year before, I was substituting for Mrs. Roush, and I was teaching what I thought I should be teaching, and she raised her hand and says, "Are we going to get an assignment today?" In other words, are you about done talking? Okay. Little did she know. Okay. Okay, negative 71 pi over 2. First I'm going to change that to this. 2 goes into negative 71, that'd be a negative 35 and a half. Okay, so you gotta be able to do some work with fractions here to divide that to get negative 35 and 1/2 pi's. Okay, now we're in good shape. I'm in good shape. Every even 2 pi it starts over. It's my cosine curve. Quarter, half a circle, quarter of a circle. Where do I start? It's negative 35 and 1/2 pi. How about negative 36 pi? Here would be negative 34 pi. Here would be negative 35 pi. So negative 35 and a half pi's would be right in between these two. Again, my spacing is not the best, but it's going to be right there. That is going to be 0. Okay, finish the other problems on the bottom of this page, and then Mrs. Begman can give you the answers for this. And I think this is the last tape I'm making. Hopefully I'll get back from Germany, won't get thrown in jail in Prague, in the Czech Republic. Hope I don't offend anybody over there with our being an ugly American or something like that. Hope to have a good time, and hopefully I'm refreshed, and you guys are refreshed when I get back also. Okay, we'll see you in a few days.